Hello, pre-calculus students. For section 6.1, I needed to discuss the difference between polynomial functions before I can get into the exponential functions. So let me come over here to Excel. And I have 1, 2, 3, 4 functions here. And it's pretty straightforward with the x. So the first change of y equals bottom minus top. Okay. And then I can click and drag. And the first change of y, the difference how y changes each time, is the same. And the function itself right here is 0.02 times x. So that's x right there. This one is a linear function, and the first change just gives us the 0.2. Now, as you're in pre-calculus, this is kind of handy because when you start taking derivatives, the derivative is right there. First change. So let's come over here to the second one. And same thing again. Equals okay, sorry, I was still in the formula side up here, so I need to get 0.2 in there. Okay. 0.2, hit enter. Now I can come over here to this next one. Okay, first change equals bottom minus the top. Enter. Okay, what in the world did I hit? Okay, bottom, top. K3 minus K2. Yeah, that's it. Okay, negative 4.9. So click and drag. These aren't the same. So I'm going to do another change. Equals the one below it minus top. Enter. Click and drag. Now we're all the same. So when I look at the formula, I'll notice that the power of the formula is 2. This is really x squared. I can't make it bigger, but maybe I can zoom. Let me pause. Okay, so I zoomed in. This is like saying x squared. And as we did the second difference, and then we multiply it by that number, 0.3, what was that second change? Let me pull it over. 0.6. So when you get to your calculus, you start talking derivatives. By the time you take a second derivative of a quadratic formula with power 2, you'll see what the second change means. Okay, so coming down here, let me pause again. I can only change the screen size if I pause. So, same again, equals this one minus the one above it. Enter. Pull it down. Oops. Wow. Okay, it almost looked the same. Equals bottom minus the top. Pull it down. Almost looks like a linear equation. Equals bottom minus top. Pull it down. Alright, so we went 3, change of 3, to get to to where it was actually constant. And sure enough, the function here, move up and pause. Okay, the number here is like x raised to the third power. So we had to find 3 differences to recognize this is a third power of 3. So, do you want to bet on the last one? I just had a thought. Maybe I'll show you. No, I'll do the same thing. And then I'll show you the formula. Equals bottom minus top. Enter. Nope, not constant. But I'm going to click and drag the formula over. Because still not constant. Still not constant. Now it's constant. It took 4 changes to get to a constant number. And the equation, moving the screen up, and let me pause so I can zoom in. This is like x right here. So, and then I just added the 3rd degree polynomial behind it. But that was the highest power. It was x to the 4th power, and it took 4 differences to get down to constant. This is how we almost define linear, not linear, but polynomial functions when you get to calculus. So I'm going to stop here and introduce section 6.1.